Solid-state batteries are at the center of discussions about the future of electric vehicles. Imagine a technology capable of completely revolutionizing the automotive industry, making electric cars faster, safe, and efficient. This innovation has potential to redefine current standards, exceeding the limitations of traditional lithium-ion batteries, which use liquid electrolytes. Instead, solid-state batteries employ solid material, bringing impressive advantages and raising the technology level. One of the biggest advantages of this new generation of batteries is security. As its structure drastically reduces the risk of overheating and explosions, electric vehicles become even more reliable. In addition, the higher energy density allows you to store more energy in less space, which optimizes car performance. What's more, one of the most critical challenges of electric mobility, the recharge time, can be significantly reduced, bringing the user experience closer to that of a combustion car. Another revolutionary point is the impact on autonomy. With superior energy efficiency, these batteries can offer much greater autonomy by load, eliminating the so-called reach anxiety that still worries many drivers. This change has the potential to propel the acceptance of electric vehicles in the market. And of course, Tesla could not be left out of this trend. Known for always being at the forefront of innovation, Elon Musk's company has already shown interest in solid-state battery technology. The possibility of integrating these batteries into their advanced models equipped with 4,680 cells has generated great enthusiasm among investors and fans of the brand. After all, Tesla has a history of leading transformations in the sector, and this can be another revolution with its marked name. However, like any technological advancement, there are still challenges to be overcome. The manufacture of these batteries is extremely complex. Some engineers come to compare it to try to paste double-sided tape chips, illustrating the difficulty of aligning tiny battery elements accurately. Even so, recent advances show that solutions to these obstacles are under development, paving the way for a large-scale adoption. In addition to technical benefits, this innovation can also have a significant environmental impact. Solid-state batteries can reduce dependence on rare metals, such as lithium, and allow the use of more sustainable materials. The replacement of liquid electrolyte with solid eliminates the risk of leaks and corrosion, increasing battery life and reducing the need for frequent exchanges, an advantage for both consumers and manufacturers. The market is already moving quickly in this direction. Companies such as QuantumScape and Solid Energy Solutions are at the front line of the development of solid-state batteries. With promising advances, the race to see who will be able to market this technology on a large scale is increasingly fierce. Meanwhile, the great automakers closely follow the opportunities that this revolution can bring. In the case of Tesla, it would not be surprised if Elon Musk was already preparing strategies, if through strategic partnerships or internal research, to ensure that the company leads this transformation more. And the impacts go far beyond autonomy and recharge time. Imagine a fleet of electric vehicles with comparable or upper performance to combustion supersports, but without negative environmental impacts. With lighter and more efficient batteries, cars could be designed to be more aerodynamic and spacious, further improving the user experience. For those who follow the evolution of the sector, it makes every sense that Tesla is involved in this innovation. The company has already caused profound changes by adopting LFP batteries on more affordable models and by launching its 4,680 cells, which deliver high performance at a reduced cost. Now, with the potential of solid-state batteries, Tesla can reaffirm its leadership position, not just selling more cars, but establishing a new standard for the entire automotive industry. The solid-state batteries revolution promises to turn various sectors besides passenger cars. Commercial fleets, such as electrical trucks and delivery vans, can benefit greatly as the durability and efficiency of these batteries considerably reduce operating costs. Not only does this make companies more competitive, but also accelerates the large-scale adoption of electric vehicles. The impact of this technology goes far beyond residential garages. It can redefine all logistics and global commercial transportation. Elon Musk, always ahead of trends, has already pointed out that the future of electric mobility depends on disruptive advances like this. In recent statements, he stressed the importance of developing larger and more versatile vehicles, which meet both families' needs and global market requirements. Solid-state batteries emerge as the ideal solution for this challenge, enabling the creation of SUVs, vans, and even electric buses with great autonomy, without compromising weight or interior space. In addition, the adoption of this technology can represent a huge competitive advantage for Tesla. While many traditional automakers still have difficulty optimizing current batteries, the Musk company can make a significant leap, delivering a solution that not only solves existing challenges, but also anticipates future demands. This movement would further consolidate Tesla as a reference in the electrification of the automotive sector. Another fundamental point is the impact of this innovation on recharge infrastructure. With dramatically reduced loading times, it will be essential to improve loading stations to accompany this evolution. Tesla is already investing in the expansion of its V4 superchargers network, ensuring compatibility with upcoming generations of vehicles and strengthening consumer confidence in the transition to electrification. The expectation for the arrival of this technology to the market grows every day. Analysts project that the first commercial models equipped with solid-state batteries can debut in 2025, marking a new chapter for electric vehicles. For enthusiasts, this represents more than a simple technical improvement. It is a realization of a future where innovation, sustainability, and high-level performance go together, leading the industry to unpublished levels. In terms of strategic partnerships, Tesla has a history of surprising the market by collaborating with companies that accelerate the development of essential technologies. Manufacturers like Chinese Chery, who is already investing strongly in production of solid-state batteries, can become valuable allies in this trajectory. Considering that Tesla constantly seeks solutions that combine efficiency and scale, a partnership with experienced manufacturers in this segment makes perfect sense. Now imagine the impact of a Tesla factory producing in mass vehicles equipped with this new generation of batteries. It would be a real revolution in the automotive industry. Improved security of solid-state batteries is also one of the main attractions for Tesla and its customers. Unlike lithium-ion batteries, which can overheat and even set fire to extreme situations, this new technology offers a much higher level of security. This is especially relevant in markets where vehicle safety is a decisive factor at the time of purchase. By adopting this breakthrough, Tesla would not only raise its technology to a new level, but would also reinforce its reputation as a pioneering brand with car manufacturing that combines exceptional performance and tranquility for drivers. Finally, the environmental issue cannot be ignored either. One of the great challenges of conventional lithium-ion batteries is the environmental impact of their production and disposal. Solid-state batteries promise to be a more sustainable alternative, with longer life cycles and less dependence on rare and scarce materials. This change fits perfectly in Elon Musk's view of accelerating the transition to a more sustainable, energetic future. With this innovation, Tesla can further expand its product line, making viable large electric vehicles such as trucks and buses, which today face limitations due to weight and autonomy of current batteries. The largest energy density of solid-state batteries allows these vehicles to operate more efficiently and sustainably, opening new possibilities for the sector. In short, the solid-state batteries revolution is about to radically transform the automotive industry. And, as usual, Tesla seems to be on the right track to lead this new era of electrification. The introduction of solid-state batteries into heavy vehicles can be a watershed. Imagine a semi-equipped Tesla with this technology, offering greater autonomy and efficiency while redefining transportation industry standards. This innovation would not only expand Tesla's reach on the market, but would also put it in a position to challenge traditional companies that have been dominating combustion-powered commercial vehicles for decades. Given the visionary profile of Elon Musk, it is hard to believe that this revolution is not in its plans for the future. Another fundamental point is the necessary infrastructure to support this technological evolution. Tesla is already anticipating the scenario with its V4 superloaders, designed to offer more power and compatibility with state-of-the-art batteries. This investment shows that the company does not only focus on vehicle innovation, but also an entire ecosystem that makes them viable. Thus, Tesla reinforces her position as a leader in the industry, ensuring a complete experience for her consumers, from car acquisition to efficient recharge. Given this scenario, the adoption of solid-state batteries in Tesla models not only seems like a possibility, but a natural way to the evolution of the company. The market is eager to see this promise to become reality, and Tesla is expected to be among the former to make this innovation accessible and functional. This is much more than a simple improvement. It is a revolution that can completely redefine the experience of driving an electric car with more autonomy, less concern with frequent refills, and superior performance. While some automakers are still trying to keep up with current trends, Tesla may be about to make the next big leap in the automotive industry. With solid-state batteries, the question is not just to improve what already exists, but paving the way for a whole new future, where today's limitations become something of the past. Another relevant aspect is the impact of this technology on large vehicles, such as three-row SUVs, pickup trucks, and vans. Elon Musk has said several times that Tesla does not intend to limit herself to compact sports or sedans, but also invest in models aimed at families and commercial applications. It is at this point that solid-state batteries make even more sense, as their high energy density allows larger vehicles to have competitive autonomy without compromising internal space or adding excessive weight. Think, for example, in an electric SUV that can run over 800 kilometers with single charge, even loaded with passengers and luggage. Long trips with no frequent stop-stops could be a major attraction to consumers who still hesitate to migrate to electric mobility. Considering Tesla's history to anticipate and meet the demands of the public, this segment would hardly go unnoticed. In the commercial sector, the applications of these batteries are even more promising. Companies that depend on transport fleets may have more efficient and economical vehicles, significantly reducing operating costs. Tesla Semi, for example, would have greater autonomy and reduce recharge times, becoming an extremely competitive alternative to fossil-powered trucks. This evolution is also aligned with global sustainability efforts, increasingly charged by investors and governments around the world. And the possibilities don't stop there. This technology can enable new segments, such as electrical vans for urban transport and even electric motorhomes, expanding options for consumers and companies. The versatility of solid-state batteries can make viable models that once seemed impracticable, especially in emerging markets, where the demand for electric vehicles is diverse. This reinforces one of Tesla's differentials, its ability to lead industry transformations instead of just following trends. But there's a point that certainly arouses the curiosity of many consumers. How does Tesla intend to integrate this technology into its recharge network? The answer is in the V4 superloaders, designed to operate with 1,000-volt systems and offer up to 500 kilowatts load rates. These new porters are not just an evolution of previous models, but a glimpse of the future of electric mobility. By building this infrastructure in advance, Tesla not only prepares for the arrival of solid-state batteries, but also ensures that its customers have an efficient and reliable recharge experience, further consolidating their position in the electric revolution. The integration of these new batteries into Tesla's advanced infrastructure offers a competitive advantage that few automakers can match. While many companies still have difficulty establishing reliable recharge networks, Tesla has already built a robust and constantly evolving global structure. This solidifies its position as an undisputed leader in the electric vehicle market, expanding the distance from competitors. With these innovations, Tesla is not just meeting consumer expectations, but redefining them completely. In addition, the impact of this technology on the future of autonomous vehicles is significant. Advance on solid-state batteries can be a crucial factor in enabling Tesla's plans to launch autonomous vehicle and robotaxi fleets. With greater autonomy and less need for maintenance, these cars could operate with maximum efficiency, meeting a large number of users and optimizing the company's profitability. Given these possibilities, it is impossible not to be enthusiastic. With each innovation, Tesla not only strengthens its presence in industry, but also drives the entire automotive sector to accelerate the transition to a more sustainable and efficient future. Solid-state batteries represent only the beginning of this transformation, and this new chapter is being written with the unmistakable view of Elon Musk and his team. This innovative approach also extends to the integration of new batteries with the advanced Tesla support systems, such as artificial intelligence and machine learning widely used in their vehicles. Autopilot, for example, would benefit directly from the greater energy density of these batteries, ensuring more energy to feed sensors, processors, and computer systems responsible for interpreting the environment around the car. Now imagine a Tesla Model X equipped with this technology, constantly monitoring the roads, pedestrians, and weather conditions, adjusting their driving safely and efficiently for days without the need for recharge. The union between greater autonomy and autonomous technology creates a vehicle that not only transports, but offers a carefree driving experience, redefining what is expected of an electric car. But the benefits are not limited to individual vehicles. As already shown by Tesla's energy storage projects, this technology can be taken advantage of to expand stationary systems, such as Powerwalls and megabatteries used in energy infrastructure. The adoption of solid-state batteries in these systems would make it possible to offer even more reliable and durable solutions to homes, companies, and even entire electrical networks. This puts Tesla in a unique position to lead not only the electric vehicle revolution, but also the global transition to clean and renewable energy sources. As production increases, it is natural that the cost of this technology decrease, as with many previous innovations. But a crucial question arises: will Tesla be able to keep its vehicles accessible while implementing this cutting-edge technology? If the answer is positive, the company will once again redefine the rules of the game, forcing the entire automotive industry to adapt to its pace. We are on the verge of a deep transformation in the automotive sector, and Tesla not only follows this change, but leads it. More than launching new models, the company is shaping a new concept of electromobility, where solid-state batteries play a key role. Tesla is not expecting the future to come. It is building this future now, innovation after innovation. This evolution will also have reflexes in the overall performance of vehicles. With a more stable and efficient energy delivery, sports models like Tesla Roadster can achieve even more impressive speeds without compromising the accuracy in curves and braking. This balance between power and control puts Tesla in a unique position, challenging even traditional luxury and high-performance automakers. However, the recharge infrastructure will also need to evolve to follow the advance of solid-state batteries. In this sense, Tesla's V4 supercharger technology emerges as a great strategic differential, ensuring full compatibility with this new generation of batteries. These porters are designed to deal with more complex thermal and electrical demands, allowing ultra-rare recharges without compromising the longevity of the battery. Another fundamental aspect of this change is sustainability. With safer materials and longer life, solid-state batteries significantly reduce the environmental impact associated with the production and disposal of conventional batteries. This reinforces Tesla's commitment to sustainability, consolidating her position not only as a reference in automotive innovation, but also as a leader in the transition to a cleaner and more efficient future. Now, the great expectation revolves around when these batteries will hit the market. Considering Tesla's history to surprise the world with unexpected advances, it would not be absurd to imagine vehicles equipped with this technology as early as 2025. After all, each step taken by the company, whether in developing new batteries, vehicles, or infrastructure, represents more than an evolution. It is a revolution that continues to redefine the future of electric mobility.